Welcome to this lecture video on field effect transistor. In this particular video, we are going to discuss a small introduction to the junction field effect transistor known as FET. We shall also compare the performances of FET with bipolar junction transistor, also known as BJT. Field effect transistor was first patented by Julius Edgar Leinfeld in the year 1926 and by Oscar Hale in the year 1934. However, they could not show the practical implementation of field effect transistor. Later, a team of William Shockley at Bell Labs in the year 1947 first attempted its practical application. The first type of FET was invented by Japanese engineers Junichi Nishioka and Y. Watanabe in the year 1950. Later, metal oxide semiconductor field effect transistor or MOSFET was invented by D. Kong and Martin Atala in the year 1959. Let us now compare the performances of bipolar junction transistor with field effect transistor. As you can see, bipolar junction transistor is a three-terminal device. The terminals are named as emitter, base, and collector. Field effect transistor is also a three-terminal device: source, gate, and drain. In case of BJT, the currents are marked as collector current, base current, and source current. Similarly, in case of field effect transistor, the currents are marked as drain current, gate current, source current. As you can see, the voltage or potential difference between the gate terminal and the source terminal is marked as VGS. This is the potential difference between gate terminal and the source terminal. BJT is a current controlled device. Here the output current, which is the collector current IC, is controlled by the base current, or rather the collector current is a function of the base current IB. On the other hand, field effect transistor is a voltage controlled device. Here the output current ID is a function of VGS, which is the voltage or the potential difference between the gate terminal and the source terminal. Just as there are two types of BJTs, NPN and PNP, there are N-channel and P-channel field effect transistors. BJT is a bipolar device. Here the prefix bi reveals that the conduction level is a function of two charge carriers. So there are two types of charge carriers here, electrons and holes. However, field effect transistor or FETs are unipolar device. That means here we have either electrons in case of N-channel FETs or holes, that is in case of P-channel FETs, who act as charge carriers. Let us look at the classification of field effect transistors. As I have already discussed, field effect transistors are two types: junction field effect transistor or JFET, metal oxide semiconductor field effect transistor or MOSFET. JFETs can be categorized into two types: N-channel JFET and P-channel JFET. MOSFETs are categorized into two types: enhancement MOSFET, depletion type MOSFET. Both enhancement type MOSFET and depletion type MOSFET can be categorized into two types: N-channel and P-channel. One of the important characteristics of field effect transistors is its high input impedance compared to the BJTs. Now the application of FETs are exactly same as the bipolar junction transistor. These are amplification purpose and switching purpose. FETs are more stable in terms of temperature compared to the BJTs. FETs are smaller in size than the bipolar junction transistors. BJTs, on the other hand, are more sensitive to changes in input signal compared to the field effect transistors. Let us now look at some characteristics of field effect transistor. It has high input impedance in the range of 109 to 1012 ohm. The source terminal and the drain terminal are interchangeable. It has, in this case, low voltage, low current operation is possible. It is less noisy, no minority carrier storage. It is very small in size, therefore it occupies small space in integrated circuit design. Finally, in this lecture video, we will look into a key question: why we name it field effect in the name field effect transistor. In this case, a electric field is developed by the charges present, and this electric field controls the conduction path for the output circuit. Therefore, it is named as field effect transistor. That's all for this lecture video. In the next video, we will look into the operation of junction field effect transistor. Thank you for listening to this lecture video.